ಟೆಕ್ನಿಕಲ್ ಸಪೋರ್ಟ್ ಇವತ್ತು ಯಾರು?
ಮೇಡಮ್ ನವೀನ್, ನಾನ್ ರೆಕಾರ್ಡ್ ಆಗ್ತಾ ಇದೆ ಮೇಡಮ್.
ಓಕೆ,
ಕ್ಯಾಮ್ರಾನ
ಹೇಳಿ ನವೀನ್.
ಕ್ಯಾಮ್ರಾ ಇದಾಗಿದೆ ನೋಡಿ, ಕ್ಯಾಮ್ರಾ ಇನ್ವರ್ಟ್ ಮಾಡ್ಬೇಕಾಯ್ತು.
ಕ್ಯಾಮ್ರಾ ಏನಪ್ಪಲ್ ಆಗಿಲ್ವಾ?
ರಿವರ್ಸ್ ಆಗ್ತಾ ಇಲ್ಲ, ಅಂದ್ರೆ ಬ್ಯಾಕ್ ಗ್ರೌಂಡ್ ಬರ್ತದೆ, ಫ್ರಂಟ್ ಸೆಲ್ಫಿ ಬರ್ಬೇಕು. ಬಂತು.
Yes sir, good evening sir, so you can start.
Yes madam, thank you madam. Okay, good evening students. I hope everybody is fine. Okay, good evening all. Right. So I think that everybody have worked and homework. Have you completed the homework given? Yes. Yes, good, very good. Okay, so today we are going to discuss very important two chapters. So one is called wave optics, which deals with the properties of and complex properties of a light. And the second chapter is today's discussion, semiconductor electronics. So semiconductor electronics, from this chapter, it's very easy. I'm going to tell you the tricks and the techniques, how to deal with these questions coming from this chapter in a short time, how to solve. So that definitely you're going to get a very good marks from these two chapters. Before we start, you should know the weightage of this chapter. Wave optics, from this chapter for CET, they are going to ask 3 to 4 questions. 3 to 4 questions will appear in CET. Okay, whereas in semiconductor electronics, 2 questions will appear in the exam. Clear? So write on this, mark this, marks or question, so that wave optics, from the wave optics, 3 to 4 questions will appear for the exam. And in the chapter called semiconductor electronics, we are going to get 2 questions. Okay, right. Is that audio is clear for everybody? Text me yes or no. Is that audible clearly? Yes. Okay. Okay, fine then. Okay, so let us discuss first the chapter called. Somebody is texting as they were getting some echo. That's fine. Probably their problem, I think. Yes. Okay. Let us start with the synopsis from the chapter called wave optics. Okay. So now, first of all, you should know in a wave optics there are 3 properties. One is called interference, diffraction, and polarization. So polarization has been deleted this year, and yes, you have to focus on 2 things. One is interference and another is diffraction. So much question will appear from the interference topic. Okay. So what is an interference of light? So now you know that whenever there is a one bulb in your room is glowing, and if you have one more bulb, if you make on both, then the intensity of the room will increases. Means intensity of light of the room will get increases. That's fine. So there is a condition. What happens if both the wave, means the wave coming from the bulb having same or constant phase difference, state of vibration, then both will get superposes, and yes, that energy is going to redistribution. The phenomenon of redistribution of energy due to superposition of two or more light waves is called as an interference of light. So when they superpose, means when they combine, when they mix or superposes, then we are going to get a pattern something like this. So since we are using a slit, the shape will be like this. So we get a bright band and dark band. That is bright and dark alternately we are going to get. So bright band and dark band. So bright band is due to constructive interference. Dark band is due to a destructive interference. And yes, interference we are going to get two types. One is called constructive interference and is called destructive interference. What is constructive interference? An interference is said to be constructive interference if their amplitude is maximum. Remember, what is that? Interference is of two types. One is called constructive interference, and another is destructive interference. For constructive means just know it. It's a bright point. Constructive interference means a bright point, a bright band or bright spot like that, and it's a destructive. Another type is called destructive interference. This is called dark band or dark point. Okay. So here we're having two types of an interference. Constructive interference means bright point or bright band. Destructive interference, that is dark band or dark point. Remember, here when this interference is called constructive interference, if amplitude, I will write here, if amplitude and intensity is maximum, this you should know it. If it is maximum, means intensity is maximum, means brightness is maximum, and yes, that area becomes bright. So if amplitude and intensity is minimum, then we get destructive interference. Okay, something happened? Okay. Right. So therefore, interference is of two types: constructive interference, destructive interference. Constructive means a brightness. Destructive means darkness. Or to get a brightness or bright point, the amplitude and intensity should be maximum. To get destructive, should have a minimum intensity and yes, amplitude. So okay, so to get a interference, the source is very important. That source is called as coherent source. What are coherent source? The sources which produces same phase or constant phase difference is called coherent sources. Same phase means same state of vibration of the wave. If it is same, then we get the interference. If not, we won't get. It's a very important point. Remember, if the source are constructive interference or destructive, that's a type. If the source are and coherent sources having same phase, then we get interference. If not, we won't get it. Okay. So now next, let us go to this one. Interference is obtained only with coherent sources. What I said now. Next, intensity of the wave is directly proportional to the amplitude of the wave. And the important formula, that is I is directly proportional to square of the amplitude. Okay, so now next, that I is proportional to a square. Therefore, if we have two intensity of the wave, we can find the ratio of it. That ratio is given by I1 by I2 is equal to, that is A1 by A2. So similarly, we can write I1 by I2 is equal to W1 by W2. So A1, A2 are the amplitudes, whereas and W1, W2 are the fringe widths. Okay, here there is some mistake. So it should be since I is proportional to A square, it should be square. Okay, write as A square proportional to, there's a printing mistake in the material. You can edit that and write A1 whole square by A2 whole square, because intensity is directly proportional to amplitude square. Okay, so now for constructive interference, for a bright fringe, you have a formula that is part difference is equal to, you can remember this formula, x into small d by capital D is equal to n into lambda for bright, x into d by capital D is equal to 2n plus 1 into lambda by 2, that is for dark point or destructive interference. Okay, where n is equal to 0, 1, 2, 3, etc. Okay, now, so what is the value to take the n value? That's the main point. Okay, how much value you have to take? Remember a shortcut method. For a bright point, whatever the fringe number they are given, write as it is. For a dark fringe, you have to subtract by 1. For example, if it is a fifth bright fringe, then n is equal to 5. If it is fifth dark fringe, then n is equal to 4. Subtract by 1. Got it? Yes. So, for a sixth, or let us say for a 10th bright fringe, n is equal to 10. Got it? For a 10th dark fringe, n is equal to, subtract by 1, and hence you get a 9. Got it? For a fast calculation, you remember this one. Okay, right. Yes, next, another very important formula, that is they are going to ask about the fringe width. Commonly, there will be one question from this formula asking to find fringe width. Beta is equal to lambda capital T by small d. That's a formula. So let me explain. Here there is a diagram I am going to write. These two, A and B, are called as slits. A and B are called as slits. Okay. The distance between these slits is called as small d. Here it is a slit. And here there is a source. Sorry, screen. Source will come left side. So this is a slits. Two slits, A and B are the slits. Distance between the slits are called d, small d. This is a screen. The distance between the slits and the screen is indicated by capital D. Okay, capital D is the distance between slits and screen. Small d is the distance between the two slits. Fine. So you came to know what is capital D and small d. And lambda is what? Lambda is a wavelength of light used. What is lambda? Wavelength of light used. Okay. So now what happens? The light coming from the A slit and B slit will get superposers here, and we get a pattern here. So this is called as center of that screen, and we get alternative bright and dark fringes. I'll write like this. So bright and dark fringes, bright, dark, bright, dark. You are going to get fringes like this. Okay, alternative bright and dark. Remember, the central one will be always bright, then dark, bright. It goes on like that alternatively. Now, the distance of any fringe, let us say first bright, second bright, third bright. For this, the distance of any fringe from the center is called as x. Okay, this is center. From the center to any fringe is called x. The distance or gap between the two fringes, consecutive fringes, are called as fringe width, the width of the band. Now, let us take this one. I will take this one like this. So this is what? a gap between the two fringes called as fringe width. Now, if we draw a line here, the angle between the horizontal and the line joining this one is called as angular width. That's the next synopsis point. The angular fringe width theta is equal to, you can write as beta by d is equal to lambda by small d. Okay, understood? This is very important. If you know this, and remaining everything becomes easy to solve. Okay, now that is indicated by theta. What if the entire apparatus or arrangements are placed inside some material like water, etc.? Then the refractive index will